So background information. I don't like to extend my explanation because I know I have I just need 10 minutes to provide everything, to show everything. So background information. Background information. The permanent cathodic protections need value from voltage. If you ask how many voltage I need according to the NAC, the standard and code. I depend on the standard and code for NAC. Just need from minus 0.85 to minus 1.2 volt DC to supply voltage to supply permanent cathodic protections. To maintain permanent cathodic protection reach to 25 kilometers. So every one station, every one transformer for permanent cathodic protection system reach to 25 kilometers. Every 25 kilometers I will install a new transformer. So in this project I suppose and I give one pipeline for 3 layers. This one pipeline length 100 kilometers. So with 100 kilometers I need 4 CP, 4 transformer CP stations. Every 25 kilometers I just need one for every 25 kilometers. So in this project, to maintain permanent cathodic protection reach to 25 kilometers for oil pipeline length for every 1 CP stations. The current problem is that the current cathodic protection, as I said before, we depend on the temporary cathodic protections which replace every 2 years to replace and change anode magnesium. The methodology and theories in this system, in this project, I depend on the PVSys and MATLAB Simulink software are used in this project. MATLAB to simulate for everything, to perturb and observe and MPPT control. I found to study an MPPT, maximum power point. And again, also I use PVSys to find how much current and how much battery current and how much the PV radiation from solar in Iraq, because you know every site is different from others. So I depend in the PVSys software also, and I depend totally in mathematical calculations to find standalone off-grid and the permanent cathodic protection system. So the results for that I use this table show the calculation for CP system. The load quantity 1, because I have just one pipeline 100 kilometers. For, as I said, for every 25 kilometers I should to install and design one PV and system and cathodic protection system. So the load quantity 1, the load rating 840 watts. Voltage rating I use 24 volt DC. The total power consumption continues in watt 840. The runtime hours per day 24 hours per day. The efficiency I use 95%. So energy consumption watt hour per day is 21,221.1 watt hour per day. The energy consumption ampere hour per day 884.2 ampere hour per day. The result calculation for load. This result calculation for CP system, for cathodic protection system. But also I found the results for calculation for load. The load I use total maximum load, because I use margin here. 10% design margin and 20% future load is 92 watts. Maximum continuous and terminal load is 1149.5 ampere hours, and load consider solar power sizing with cathodic protection system 1171.3 ampere hour per day. Discussion here. The study apparently discussed the installation of off-grid PVSys in remote area in Iraq. I used PV panels are connected based on the initial science result. A 29 PV solar I use in parallel, and just one in series panel for every 1 CB system. CB, that's mean cathodic protection. So I used for every cathodic protection system transformer standalone off-grid PV system with 29 PV in parallel and 1 series panel for every 1 CB. So I use 4 CP stations are calculated and designed for one oil pipeline with 100 kilometers length, every 1 CP for every 25 kilometers. I use 24 volt DC with 50 amperes with every CP. The output of PV model can be maximized use MPPT control system. I use MPPT, maximum power point, and I use this algorithm. I use code in MATLAB because to find the maximum power point tracking, to find the high percentage to irradiation if we have in different environmental. So I use also 2V cells with 48 cells are required to supply power to the system. The conclusion for my project, this. I supplying the required energy for catalytic protection system with 21,221.1 watt hour per day. I provide energy for the system without getting fed from PV panel for 5 days is. So the energy system without any PV with 5 days is 884 ampere hours per day by lead as I use lead acid battery. And also I use battery charging system. It's very important to use battery charging system to maximize between PV and battery. So I use battery charging system with maximum power point tracking, unit with P&O approach has also considered and implemented. The load considered for solar power plant for cattle protection system is 1,171.23 ampere hours per day, and the total maximum load with 10% design margin and a 20% future load is 1,092 watt. Sorry because I summarized everything, and thank you again to Mr. Musa and Dr. Gao to support me for everything. I hope you like this. I don't know, maybe you like, maybe no, but actually I tried many times before to upload in the portal, but I can't. So I agree with Dr. Musa to send this PBT booster to make a presentation and send this by email or WhatsApp or anything else. Thank you again. Thank you for everything. Really I interesting before to make this project because really I get benefit to how design, how to make Simulink, how now to make design and calculation mathematics. So thank you again. Thank you very much.